This section is on trapezoids and kites. We will be looking at the difference between an isosceles trapezoid and a regular trapezoid, and we will be looking at the properties of kites and trapezoids in general. Trapezoid, remember, by definition, has exactly one pair of parallel sides. Also, because of the fact that these are parallel sides, we'll put the little parallel symbol in there. Because our sides are parallel, the corresponding base angles would be supplementary. We would consider these same side interior angles. So this angle and this angle would add up to 180 degrees, and this angle and this angle would add up to 180 degrees. Same thing in an isosceles trapezoid. You look at the parallel lines, and then one base angle and one base angle would be supplementary, and then the other pair. In an isosceles trapezoid, these things hold true. The definition, obviously, there's one pair of parallel sides. We'll put the parallel lines in there. And these angles still would add up to 180. They would still be supplementary. On top of that, these three things are also true if your triangle is isosceles. What makes it isosceles is the non-parallel sides are congruent. So the length here and the length here have to be the same. That's what makes it an isosceles trapezoid. Just like an isosceles triangle, you have two sides that are equal. Because of that, the base angles themselves would have to be congruent. So not only are these two supplementary, but these two would be congruent to each other. Okay? So these two are supplementary, and these two would be congruent to each other. The last piece is that the diagonals, remember if you draw a diagonal, it goes through from one vertex to a non-adjacent vertex. Diagonals would be congruent. You can see that the distance from here to here would have to be the same as the distance from here to here. That would not hold true in a regular trapezoid. These three things only hold true in an isosceles trapezoid. So using what we know about isosceles trapezoids, we can use those characteristics to find missing lengths or values or whatever it is we're trying to find. In this case, notice that this diagonal is 7y minus 3 and this diagonal is 4y plus 6. Well, we know that if our trapezoid is isosceles, that the diagonals would be congruent. So we would set 7y minus 3 equal to 4y plus 6, and we would solve using our algebra skills. So we would subtract 4y and get 3y, and we would add 3 and get 9, and therefore y would be 3. We can then plug that back in if we need to know the length of the diagonal. 7 times 3 is 21, minus 3 would be 18. So the length of the diagonal would be 18. Same thing here, 4 times 3 would be 12, plus 6 would be 18. And then because these are isosceles, not only are these 1 and 2 supplementary and 3 and the 49 are supplementary, but the 1 and the 49 would be congruent and the 2 and the 3 would be congruent. So what's nice about an isosceles trapezoid is if you know one angle, you know all four. Angle 1 would have to be equal, so it would have to be 49, and then to get what angles 2 and 3 are, you'd do 180 and you would subtract 49 from it and you would get 131. So angle 3 would be 131 and angle 2 would be 131. Kites are a little bit different. There's two separate parts to their definition. One part is that it has two pairs of congruent adjacent sides. Okay, so that means that two sides are next to each other and have to be the same length. So that's why these tick marks are here, showing that these are congruent adjacent sides. And the two sets of tick marks are here because these two are also congruent and adjacent. So here's one pair, here's the other pair. The second part of the definition No opposite sides are congruent. The reason that they say that is because if these were congruent, that would make all four of them congruent, and then it would be a rhombus, not a kite. So those two pieces are both part of the definition that make a kite. Basically, it says you've got congruent adjacent sides, but it can't be a rhombus. That's basically what those two pieces say. Because of the definition, these are the characteristics of a kite. The diagonals are perpendicular. So if I draw in the diagonal, so that should be straight from there to there and there to there. Perpendicular, remember perpendicular means right angles. So that means all four of these angles at the center here are right angles. The other characteristic is that the longer diagonal, this one here, would bisect. Remember, bisect means cut in half. It cuts in half the angles, creating symmetry. Okay, so this half of the kite is exactly the same as this half of the kite. These two longer triangles here would be congruent. This angle would be the same as this one would be the same as this one. We know our sides are congruent by the definition, and then it bisects the angles, so those angles are congruent also. So the longer diagonal cuts the kite into two symmetrical pieces. The shorter diagonal does not. You can see that this triangle would not be the same length, same shape as and size as this one. Okay, so using those characteristics, some examples that would go with kites. Here we know that this angle is 64. This is the longer diagonal, so it cuts the kite into two equal pieces. So everything over here is the same over here. So if this is 64, we would know that this is 64. I did not draw that 4 very well. 64. We know that the diagonals are perpendicular, so we know that angle 1 would be 90. And then to figure out what angle 2 would be, this is a right triangle. So we would say 180 minus 64 and minus 90 would give us 26. So angle 2 would be 26, because this would be 154, and then 26 would be what's left. All right. The next one, if the diagonals are not drawn in, remember that longer diagonal would still cut the kite into two equal parts. That tells you that angle 1 here and angle 2 would have to be congruent to each other. Now, you can go ahead and draw the diagonals in if you want and do what we did here by creating triangles. You can figure out the angle measures. But notice that this is just a four-sided figure. Any four-sided figure, the angles have to add up to 360, just like a rectangle, square, whatever. And we know two of the angles, and the other two have to be the same. So if I take 360 and I subtract the 80 and subtract the 46, I get 234 degrees for what's left for those two angles. And so then if I divide those, if I divide the 234 for what's left for those two, if I divide that by 2, I would get, they would both have to be 117. That's the end of this lesson. Please check your pacing guide to see what your suggested problems are.